Hello all, welcome to this short video on case study on corrosion failure. My name is Dr. K. Ilay Perumal. I am a corrosion and metallurgical consultant. There are several reasons for corrosion failures, starting from design, fabrication, material of construction, metal quality, process control, process impurities, process treatment. Any deficiency in all these aspects will lead to corrosion failure. At the end of this lecture, we will see this particular corrosion failure has been contributed by one of these reasons. In this case study, we will talk about autoclave leakage. Autoclave is a pressure vessel used for carrying out certain chemical reactions on a laboratory scale. This is the sketch of the autoclave. You can see the autoclave body here, and you can see the top dish tent, and it is made of 316 stainless steel, a thick wall vessel, because autoclave is supposed to operate at very high pressure inside. Chemicals are added here and reactions are carried out and the final products are analyzed. And this is the laboratory autoclave. Unfortunately, leakage occurred and quite unexpectedly, sudden leak occurred somewhere on this point. The laboratory personnel were not very clear where exactly the leakage is occurring so far as the inside reactions are concerned. This is a section of the autoclave. You can call it elevation of the autoclave. This is the thick wall, and this is the thick bottom. All are very thick because they have to hold the pressure. This is the leaking point, and it is conforming to somewhere in the middle of the autoclave. After opening the autoclave, the leaking point was found to be corresponding to this edge, and corrosion has started from the edge and went like a crack towards the outside, resulting in leaking. You can see the difference in dimension, and the inside wall was having a height of 42.5 mm. The corresponding outside wall up to the point of leakage is 45 mm. So you can see there is a flow of liquid due to gravity. So the leakage is due to corrosion from this edge and progressing towards outside, resulting in leaking. This is a cross section. This is a fracture surface of the crack. That means you are looking from top to bottom of the fracture surface. This is corresponding to the inside surface of the autoclave, and this is outer surface of the autoclave. And you can see the difference in the fracture characteristics. This is divided, the cross section, the wall cross section, as seen from above on the fractured surface, is divided into three regions. Region 1, very close to the inside surface. Region 2, somewhere in between, and region 3 corresponds to the outside surface. You can see the difference in appearance. This slide shows scanning electron micrograph of the fracture surface, usually called SCM. The region 1, that is very close to the inside surface, is shown in a very big magnification in this scanning electron micrograph. This is typical of intergranular corrosion. This means corrosion has proceeded along the grain boundary and the fracture surface, it looks like this. This is called intergranular fracture or intergranular corrosion. The region 3 is having a different type of fracture. You can see the difference here between this and this. And region 3 corresponds to the final fracture end. This is called the final lip fracture. You can see it is a very fast fracture. This is almost a flat surface compared to the grain-like surface here. And so this is intergranular corrosion after the thickness reduced from inside towards outside. This final lip fracture has occurred. So this is the final mechanical fracture. The progress of corrosion you can see from here out, from inside to the outside, starting from inside towards outside. So this case study involves corrosion from inside slowly developing towards outside, corrosion under pressure. Here you can see the cross section as seen in the autoclave which failed. The point to be noticed here, this wall is very sharp. This corner is very sharp. And this is where corrosion has started and progressed towards outside. So this sharp corner is not acceptable. Once you compare the cross section as per given drawing, this is as per given drawing as compared to the as seen in the fabrication. The main difference between this drawing and the earlier one is this is a smooth surface. This is the designed as per the drawing. So any smooth surface will not allow any corrosion to take place. On the other hand, in the previous slide, we saw sharp corners. Under the sharp corner, corrosion has taken place, and due to gravity, the liquid started flowing downwards and resulting in leaking. So the diagnosis of this failure is the inside bottom edge was not chamfered during fabrication. Chamfering means make it smooth. So, and that resulted in a circumferential crevice throughout that sharp edge, and entry of the corrosive liquid into the crevice under pressure. This is very important. This is under pressure, so that the liquid is not easily coming out. And gradual corrosion under pressure during the campaigns. In spite of being a stainless steel, when the liquid remains stagnant under pressure in a very tight corner, the corrosion will take place. This corrosion continues because the entrapped corrosive liquid does not come out during washing between the campaigns. A campaign means a product development. Whenever they have developed a product, before they go to the next product, they do washing. That washing is normally done at atmospheric pressure. It is not a pressure washing. So the liquid remains constant inside and continues to corrode. So corrosion down to a certain thickness, that is what intergranular corrosion, followed by mechanical overload fracture. Once corrosion has reduced the thickness, the remaining thickness will not withstand the pressure. It leads to mechanical overload fracture. So this is a case of corrosion due to improper fabrication. You can recall the several deficiencies it was mentioned in the beginning. So this is a deficiency in fabrication. So this is the very important aspect of corrosion prevention. Fabrication should be proper. So the recommendation to prevent this failure, uh, the corners, edges, and turning points in any fabrication of any vessel must be chamfered smooth and not sharp in all fabrications. And this is particularly important in high pressure autoclaves because autoclaves work under high pressure and these sharp corners will initiate corrosion and lead to leakage. So the takeaway in this case study is corrosion of a high pressure autoclave is due to fabrication defect. You can see here the design and fabrication was the first major clause. So this is a defect due to fabrication. Thank you very much. And this book you see here, it is Corrosion Failures, written by Professor Raja of IIT Mumbai and me. And this book will give you many details about corrosion failures, theory, case studies, and solutions. And this book you can get through Amazon. Thank you again.